Okay, I got my screen shared. So I want to talk today a little bit about object-oriented programming before we get into some of the other things. Um, just because of some of the issues I saw in the last assignment, um, and this was not. This is definitely not directed towards any one person. I saw this on multiple cases, multiple people, um, and multiple types of errors, just not understanding some stuff, I think. So I just wanted to kind of go over um, what you can do, what you can't do. Some of this is going to be kind of C# specific. Some of this is going to be um, much more generic, if you would. So the basic premise, if you would, and let me pull this up just so you can kind of see it in uh, the idea of how we're working with this, is in object-oriented programming, there are three main concepts that you need to understand. Um, the object-oriented programming, generally, when it's, especially when you're first learning about it, is thought of people, places, and things. Okay, i.e., nouns, if you would, if you're thinking from a like an English grammar type perspective, what we would call a noun. So you have in your objects, you're going to have people, and generally you want to make sure that they are generic people. I have a student. Well, I'm not saying I have Kate as a student, not yet, at least. I'm saying that my class, which is going to be my blueprint from which all student data objects are going to look like, is going to be very generic. I don't want to have anything specific to Kate in there because I need to turn around and also use it for Denise. And I've got to be able to keep it that level where I have that um, option, if you would, for lack of a better term, to uh, be able to be generic so I can use it for multiple people. Um, and so that's kind of a real important thing. If I have a house object, I might have a number of bathrooms, a number of bedrooms, and a square footage, and an address, and stuff like that. These are things that all houses are going to have. Um, I'm not specifying that the house has to be at a specific location. I'm letting it be kind of wherever. That's because the class definition is my blueprint. And my blueprint is not something where I can like go live, if you would. Okay. I can't live in my blueprint, but it's going to tell me how to make my house. Okay. My class is going to define how to make my objects. The objects are what I'm going to actually use. Okay. So that's kind of an important thing. The other big thing we need to keep in mind is, though, that the things part can be an abstract thing. It doesn't have to be a concrete. It doesn't have to be like a piece of furniture. It doesn't have to be a thing like a plant. Okay, those are solid, um, literal objects. I can have abstract objects like a data reader or a conversion object, like we did for our example with the Roman numerals to numbers and vice versa. Okay, so how we use them is going to be the same conceptually, but sometimes we have a hard time wrapping our minds around it because it's not something we can physically look at and go, oh, well, there's, four legs in this chair, and so I need to have a number of legs because I might have a different number of legs for some other piece of furniture. Okay, so it's a little bit different than that. We have to just kind of keep that in mind, and we have to think about how are we going to use it, what it need to do. It makes that we need to do our planning a little bit more intense when we think about and we're planning about how we're going to build this object, but that little bit of pre-planning is going to make the development phase and stage of the process a lot easier. Okay, and I'll give you a personal example from many years ago that I did. It was it was actually my first job out of college, um, and I was tasked to rebuild this particular application. And previously, when they had built, it was kind of like an online math game, for lack of a better term. When they had built these previously, each stage was built individually without consideration of the other stages. So you had to have its own separate server application, own separate front end application. There was just a lot of issues with that. It was not maintainable at all. At all. Not only that, they built 3 modules in about 12 to 14 months, something like that. And so I said, well, I looked at it and I talked to my boss, says, look, here's the problems. It's not maintainable. It's got these issues. Says, let's rebuild it from scratch. And that was a pretty easy sell for him. And so I went to work on designing the whole process out. And I started sitting at a table and sketching um, how data would move from one element to another and what types of data properties we would need and all this type of stuff. The um, the only time I got on the computer for the first like 2 weeks was to check my email in the morning and after lunch and stuff. And then I would just go straight into working at this desk using pencil and paper. Well, my boss came to me about 2 weeks later and he's like, so what have you done? I says, well, I've been working out this problem. I worked out that problem. I sketched this all out. And he goes, yeah, he says, but, people are talking that you're not getting work done. You're just, you're just goofing off and drawing and stuff. He says, well, I'm not drawing. I showed him. He says, yeah. He says, you got to get on the computer. People are talking. I said, okay. So it says, can you give me like one more day? It says, I need to finish this up. I'm almost finished. It says, and then I'll be on the computer. I can do this. He goes, okay, sure. So I finish up that day and I come in the next day and I start working on a computer. And because I had taken all that time to kind of plan out that process. Like I said, it took about 2 weeks. But because I had spent that time where the last group that had worked on that project had done 3 modules in about 12 to 14 months, I built 4 modules in about 4 months. And so the amount of time to take to build it went way, way down because we had planned and we really, really knew and understood what was going on. And that was a much more complex than anything that we've seen in class. I'm going to be completely honest with that, which is why the design time took um, about 2 weeks. I did the conversion process. I thought that'd be a fun little, assignment, and so I built it as well. And I spent a few minutes kind of figure out, okay, how is this going to work? And because for that size project, spending 15 minutes, 20 minutes was all the time that you really, in all honesty, needed. Um, so you want to think about, especially because it's something like that, which is very abstract. You know, you can't look at an actual converter. How do I convert data from here to here? Well, there's not a physical one you can look at it and say, oh, this is how they're doing. This is how we're mimicking. We had to come up with something and start to think about the ideas. So I just started thinking about, okay, what types of data properties are going to be stored in it? What types of inputs and outputs am I going to get? How is this going to work? And so I started thinking about that whole process. Um, the whole idea of having these, uh, for lack of a better term, having these data properties and stuff like that, it's all known as encapsulation. We're going to take that information and encapsulate it as one whole piece. How we going to use that's going to be important in just a little bit. The other part that we're going to get with encapsulation is going to be a certain level of protection or data security. So when you encapsulate information, you are trying to work on making it more secure. Um, Other objects can't go and access that data, and that's a good thing. Um, how you convert data becomes a black box. You don't want to see the inner workings. You just want to say, hey, I give you an integer, I get a string out. I give you a string, I get an integer out. those types of things. It needs to be very, very black box. So we're going to look at that. That's part of encapsulation. Inheritance, I'm not going to look at just yet, and I'm not going to look at uh, well, I can look at the polymorphism if you want. Polymorphism is the idea um, of kind of like function overloading. You should have seen that like in C++, and you might have seen it in C# with some of the examples we've done. Um, you probably saw in other languages, polymorphism, the idea of overloading where I have the same function name, but it works differently depending upon what data I pass into it. So if I take um, two integers and pass in two integers, it behaves a little bit differently than if I pass in two doubles. And in passing in two doubles, it's actually a different function. It says, oh, wait a second, I've got two doubles, not two integers. Let me go here and get this to work for you. That's the basics, real high level idea of polymorphism. But when we implement the idea, when we start building it, we got a few things we need to understand. And the first thing we need to look at is our constructor. And our constructor is going to be very simple. A lot of people try to do too much work inside of a constructor. So let's look at what a constructor looks like. I've got over here my converter data type. And you'll notice I don't even have a constructor in this. Okay, so I don't have a constructor. This is going to be what we refer to as a static class. Okay, we never need to instantiate into a class. We're going to use the static methods of this class. So I don't even have a constructor. Okay, my constructors should be so simple that all they're going to do is assign values from one place to another. Okay, that's all I need to worry about. I don't need to worry about, or I shouldn't be worrying about file IO inside my constructor. Not needed. Okay, I shouldn't be worried about uh, converting data necessarily. I might have a little bit of lightweight conversion stuff to do, but I should never have any big, heavy uh, data conversions inside my constructors. I want to keep my constructors light. And by light, I mean very fast to operate. The reason why is if I'm quick to operate my constructor, then my application, every time I go in and create something, is very fast. And that's a key component. I want that speed. I want to do everything I can to speed up my application. And using a constructor, because of how object-oriented code works and how we separate namespaces and memory space and stuff like that, it takes time to construct. So anything I can do to speed this up and make it as lightweight as possible, I'm going to do. So if we think about our converter, you might say, well, I need to give it a string and then have it convert. That's a big process of it, but that would slow me down. So how do I do that? Well, this is where we use those static functions. So if I don't have a object of information, because I don't need it, I'm only converting data. That information is very transient. Okay, it's transient meaning that it comes and it goes. It doesn't stick around and stay. If I'm building an application, let's take an example. I'm building an application and I'm doing something with a student um, processing application. I need your student data to stick around. I need to create a class and then I have an object for student and it's going to have all the information about you that I need to know. Your name, your address, an emergency contact, your major, expected graduation date or year, number of credits you completed, who your advisor is, all that type of stuff. Okay, I need to keep that in because that stuff is going to be used over and over and over again. Maybe it's not used on every screen. Maybe it's not used even every time. But that information I'm going to get, I'm going to need to have that information and use it over more than just that one or two lines of code. When I'm converting data, it's transient. Data goes in, data comes out, and I'm done with it. I don't have to worry about it. I could just write a function inside my program So why would I create a class for it? Well, creating a class for this allows me to now take it to another application and use it over there. So that's the idea of the code reuse. So I've built a class. It's a conversion class, but I might need to use this over here in this other um, example that I have, this other program that I have, whatever. And so this is by putting it inside of a class, I can use it in multiple projects very easily. But I also, since it doesn't need to store data, I'm going to use static methods to encourage the transient nature of this data. So here, for example, is my class converter, and I have a public static int Roman to Arabic, and it takes in a string called Roman. Let's look at what each of these does. So public is my access modifier. Who's allowed to see this? Anyone is. It's public data. So I can let as many people see this as I want. We're all good. Mwah, thank you. Okay. Static is the special keyword that I want to really focus on. So we've seen the word static before, and we see it if we come over here to our program.cs, we have static void main. Okay. And static is doing the exact same thing in this instance. So static says, I don't have to create an object from this class. I can just call this method. And the way I'm going to call this method is going to be very simple. I'm going to specify the class name, dot, and then the static method. Now, behind the scenes, it's doing several things for us that if you're like really focused on how programming languages work and how the compilers work and stuff like that, there's a lot of stuff that goes on behind the scenes that it's doing when it sees something like this. So it's going to come over here. It sees my Roman to Arabic static method. It says, oh, okay, as a static method, I know a few things. Number one, as a static method, this function is shared amongst every instance of my objects. So if I want to create a bunch of objects and I happen to have a static method, normally an object gets its own copy of all of its properties, all of its methods. Those are all duplicated. And that's part of the reason why creating an object is a time-consuming process. It's got to create its own copy of its methods and properties. It's got to go out there and do that, and that takes time to set up. And it's got to make sure that only it can see its own methods and properties. When we say static, we say anyone can access this. But that's going to do a couple of interesting things. It means that it can only access, a static method can only access either local variables that are created inside of its method. So for example, this string here, which was passed in as a parameter, this dictionary object here, okay, my integers here, my string here, those are all perfect examples of things that are local variables. So I can access those. I can also access other static property, class level properties. Once again, those are going to be shared amongst all my objects if I have them. Now, in this case, I didn't bother with them. I cannot access an object-specific property. I cannot access an object-specific method. That's my limitation of using my static. The advantage is I can call a static method without having to call and create the object. So I get a speed improvement, I get a memory reduction, but everything has to be shared. And so I've got limitations, I've got advantages. Just kind of depends on which one do I want to work with. Okay, so that's the big idea behind static. Everything else then starts to fall into place, and we see this and we go, oh, I remember this from way back when I was doing, C++. So this is easy. I've got my return type. In this case, it's an integer. I've got my function name or method name, because it is technically in a class, and I have my parameter list. Okay, and so everything else is basically the same, but that static has those special rules about it. Okay, now with a static method, typically I don't want to do too much setup work. I really don't. Once again, the reason why is it takes time. It takes memory processing and resources, and that stuff I may not want to spend a bunch of time doing. Okay, so every time I call a static function, I've got to reset it up, and that can be time consuming. So actually, when I did this particular example, I went back and forth and said, well, should I create a static method, or should I create um, an object and have it all set up, and then I only pay that setup price once, and I just call a conversion method. Um, this was a decision I made. It's not necessarily the best decision. It's not the only decision. It's not the worst decision. It worked, and that's the key component. And part of the reason why it worked is I want to show you stack methods. Okay, so I've got my dictionary object. I created. I add elements to it. Those are my numerals, and then I run through my loop. Um, you'll notice there are a few things in here it will give you kind of like little warnings on. This is a Visual Studio thing. It says, hey, you gave this a current, you gave this an initial value. You really didn't need to. Fine, whatever. It does this to me a couple times for letter and also for current. Big deal. Okay, so I get my letter. I get my current. My current is the current um, get value or default of my letter. Okay, so it's just a quick little process. Um, what I'm doing, excuse me, is I'm looking, just so you kind of understand what it is I'm looking. I'm looking at my Roman numeral string that comes in for int I equals length minus 1, I is greater than 0, I plus I minus minus. So I'm working from the left side of my string to the right. I'm working in the direction that you read it left to right, but it's stored the other way around. Okay. And what I'm going to do is I'm simply going to come in here and start reading and removing items. So if I see that you have an M, then I'm going to say, okay, get from numerals, which is my dictionary item, get the value of that letter. So this is my key. I'm passing it essentially a key, and I'm getting an integer number from it. If my current number is less than my previous number, okay, I'm sorry, I'm reading this from I'm reading right to left, not left to right. I said that backwards. Reading right to left. If my current number, okay, so I got a value, and let's say I got a 1, but my last one I got was an X, 10, okay? 1 is less than 10. That means I need to subtract my current value from my running total. Okay, and that's simply what's happening. That was just to keep track of, hey, you had a 1, and now you have, or you had a 10, now you have a 1. IX, which is 110, that's not 110, it is 9. Okay, and it just lets us kind of keep track of those types of things. If it wasn't less, so which means it's the same or more, then we add it to the running total. Then I set my previous to be my current. Okay, so this way I can have like IIV if I'm reading right to left. I can see IIV, and then I can see X, then I can see 1, and then I can see X, and I can get a value from that information. I can work with that. where I can see a C and then a 1. I can work with information like that. And this just lets me know how to keep track of that, just by simply using a little loop and going through each of these values. Okay. Because this is a static method, I return my running total because I have a return type. Returning something is not required. I could have a return type of void. Once it's done, it goes away. I don't have to worry about it no more. Okay, so that's where I'm saying static methods are very beneficial. Is I didn't have to go through the process of creating a whole object to do this and whatnot. But, big but I do lose all my information. I have to recreate it again. So I have to see if that's worth it. Likewise, I have a static Arabic to string. In this case, I use two arrays, one for my numeric value, one for my letters. And so I specify 1,000, that relates to M. So these are all in sequence. 900, that relates to CM. 500 is D, but 400 is CD. If I want to create something to have like, instead of just CM, I wanted to have XM, I could have put in an XM, but I was just kind of keeping it simple. Okay. This takes in a numeric value, and I want to return a string. Once again, it's also static. It's also public. So I give it a number, and I literally go through values, or 0 through values.length. Values is my integer array. And while the value that gets passed into it is more than values at my first I, my return value plus equals what my letter is. So M, MM, MCM, whatever. And I subtract the values element from my value. The idea being I subtract my numeric value of 1,000. I don't have it anymore. Don't need it anymore. It was 1,900. Now I'm down to 900. Okay. This isn't a while loop, so I can keep going through this process over and over again. Okay. I have 1,900. I'm down to 900 because I took out 1,000. 900 is greater than 1,000. I exit out my while loop. I come to my for loop. Now I am at the next element, which is 900, and I just build upon this process. So if I had 1900, I could just simply do MCM, and that's what it would display here, which is what we want. Okay, it's exactly what we want. So I've got a lot of power and strength in being able to do something like this. This is very simple. This is a perfect example of a static method. I don't have complex data types I'm building. I don't have other things going on. I'm keeping it focused. And that's what I want to do. In program, I use my try-parse just to say, okay, which one am I going to go to? Which methodology am I going to go to? I don't have to go in and create a converter object. I could have, but I don't have to. I don't have to go through other things. I want to keep stuff simple. Let's take a look at what this would look like, though, if I did do the conversion process and I didn't have static methods. So what I need to do is I need to create a converter, and I need to create some class level variables. So let's just do this real quick. Class level variable. Class level variable. Class level variable. Now I'm going to create my constructor. Public converter. Okay. There we go. It's like, huh. Excuse me. My constructor does not have a return type because I'm returning that object, that data type. Okay. I'm going to set up my values here. So here is my numerals. Notice I have my object, my class level value here. So here it shows, okay? At this point, this goes away. We don't need any more. These aren't going to be needed anymore. So we can come over here and set these up as well. I don't need to redeclare them, so I'm just going to use the variable name like that. Okay. Now, remember I said that static methods cannot use class level properties that aren't static themselves. Well, if I look down here, notice that it gives me an error. It says, an object reference is required for a non-static field. So I'm going to take out static and take out static. And now we're done. Okay. This all works now. So I have some basic setup. I assign some values to my class level variables. My class level variables can be accessed anywhere inside of my methods, other methods, as long as my methods are not static. So notice I took out my static for my Arabic to Roman, and I took out my static for my method Roman to Arabic. Save this, come back to my program. This is now showing an error because these are no longer static methods. So what I'm going to do is I'm going to say converter convert equals new converter. And now instead of saying converter.Arabic to Roman, I just say convert.Arabic to Roman and convert Roman to Arabic. This way, I've defined my class here on line 16. I've defined this class, and I can now go in and use my class level or my object level methods. My object level methods now work because I have a constructor that is setting my class level variables, and then my methods here go in and run and use those class level variables. So in this case, I have one initial pain point when I initially construct my object, but then every other time is a little bit faster. So I have to kind of weigh those pros and cons. Our example, I think we had like 11 conversions by default. It probably wasn't a big deal to have those static methods. If I had 11,000 or 11 million, then that starts to really, really add up. If I come here and just run this, you'll notice it gives me the exact same lines of code that I did as output. There's no change. That's what I expected. Excuse me. And for mine, just if you notice, I have a conversion here, and I say, I write what my line is, and then I do my conversion, and this is a right line, so it goes to a new line. But this way I always know what the previous version was, and then what the converted value was. I always thought that was kind of on the important scale, if you would. Okay, which is how it gives this type of breakdown where you see IC is 99, CDV is 405, but 97 is XCVII. Okay, et cetera, et cetera. So you can go through that process. And then I specify down here how many lines there were. I just keep that as a little running total. So that's kind of the idea of your constructors, your static methods, when you want to use a static method, when you have transient data versus something that's going to stick around, but it's not required static methods are kind of an interesting thing. Um, the biggest thing you don't want to do, and I want to kind of point this out, because I saw some people do something like this, is notice I'm using my converter, the same converter object every time. You notice that? This is what I saw some people doing. And it might not have been this exact method, but it was something similar. They came in here and they had a converter object. And then they passed in a value. And then it exited. And then they came and created a new converter object. And so the process was they were constantly going through creating new converter objects. And it's a converter object, 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 and it just went on and on and on. You might say, well, what's the big deal about that? And the big deal is that what happens is I've got the penalty for creating that object every time. And I really don't need it. So whether I use a static method from my object, or I create one object, but I only need to create it once, because I'm not dealing with data that needs to be held onto and remembered and kept to be used again and again and again. So I either use a static method, or I need to create one object, spend that little bit of time penalty setting it up, and then go through calling that conversion process time and time again. And it just depends upon what is it that I'm really trying to do. And that's something you got to keep in mind when you're going through this process. Because if I have something like this, I'm literally creating a new object every time. And if I had thousands of items, I'm creating thousands of objects. And this is going to start to take up memory space. In C++, you had to go through the deconstructor, if you guys remember that. Yeah, your constructors and destructors. In C# and in Java, they have what they call garbage collection. And so as it sees that an object is no longer being needed, it gets added to be potentially collected and eliminated from memory. Well, as I start to fill it up with a bunch of useless objects, it goes, okay, time to collect this stuff and throw it away, and now I can do more. But the process of going through and doing garbage collection is time consuming. And a lot of times in a lot of languages, especially modern ones that use garbage collection, you don't even get a chance to say, hey, I want you to collect the garbage now because I'm about to do this really intense process. So I'm going to know I'm going to run out of memory space, so I need you to collect it now before I start this really intense process. Because what I don't want to have happen is to go intense process, intense process, intense process, and pause while I collect garbage, and then come back and start doing more of it. Okay, I don't want that pause in the center. But a lot of languages don't do that. Java has a garbage collector. You can call it, but it's kind of like a suggestion. It's kind of like, your hard disk defragmenter on Windows. In the old days, we used to say defragment my hard drive. It did it. Now it goes, you really don't need it, so I'm not going to bother. You're only 4% fragmented. It has no way of looking forward and seeing how much of a process you have. So this becomes troublesome, not only because you got to create objects, and when it's no longer used, they're not just disposed of, they're marked for being disposed, but it's going to be disposed of at a later time. So you're going to get a hit on both creating it and when it's garbage collected at some point down the line in the future. Like I said, if for simple little programs like this, it's not going to be a big deal. As you get into bigger programs, this is the program that people use every day, and they just leave it on, and it's left on for days at a time, or maybe even weeks at a time. Um, you're going to have to go through a lot of garbage collection processes, and you don't want to do things that make your code inefficient. So being able to have only one object and reusing that object like this, or like we did before where we had static methods, becomes a huge, huge benefit. Okay. Any questions on what we talked about so far with constructors, with static methods, with variable level, or excuse me, object level variables, anything like that that we've talked about that you have any questions on?
I don't have a question. I'm good.
Okay.
I'm good.
Okay. So that all kind of makes sense. I know this is kind of a more of a little bit high level abstract information, but just when I see stuff being used, because what we're going to be looking at when we start looking at JSON data and XML data and converting stuff and reading it, there winds up being the same process. If you remember when I talked the other day, we were talking about how your file I/O or screen I/O or any type of I/O is a time-consuming process. So if I'm reading in from a disk and having to create objects to do my conversion and then converting it and then going back and back and forth, it gets really messy. Which is why I thought, this is a really good time because I saw some of those errors. And like I said, I think everyone made some sort of error at least once in that process. It wasn't something that kept the program from running. Um, it wasn't something that was a huge performance issue for this amount of data. It's just what happens if I had more data, bigger data, crazier data. That's when it would start to be a problem. The good news is about this, and everyone has access to the book. I have started writing this out in the process of this whole process of implementing objects. I'm talking about constructors. I haven't got to the point yet about talking about uh, what was it? Static methods yet, but I'm working on that. Um, if you want to go through and read this because maybe you haven't seen this type of stuff with data objects before, um, you're more than welcome to. I want to point out where that was. It is on the book. It is a important thing that we'll be processing through. The next thing that we're going to work on. Oh, I haven't updated yet. So anyway, this is actually, like I said, does lead into it. The other thing I was going to point out, and I forgot to mention, is this method here where it doesn't take any parameters. I always like to have that default method. And the reason why is real simple. It keeps, if I pass it a value, that's fine. I can do that. Um, but I want to make sure I have a default value. And the default is so I make sure no matter what, I have my bases covered. And I'm going to set up and identify all my class level variables. Now, I saw with some projects, what they were doing is they would say, oh, public converter string Roman. Okay. And then it was like, oh, now I'm going to do all my work inside my converter. Okay. Or inside my constructor. I never want to do all my work inside my constructor. I want to have another method like this. If I've got the only time I'm going to do any type of conversion process in my constructor is if this data is going to be held on to and used later on. So if I was building a conversion object, but conversion wasn't the big thing. The big thing was storing the number. Then I might have it where I pass in a default Roman numeral value. But in something like this, it's a problem. Now, an interesting thing I can do. No, it's not this. Let me do this. No, I'm thinking of Java. Never mind. I'm thinking of Java. Ignore me. Sorry. So I'm going to skip that part. Okay. All right, that is what I have actually for today. It's about 50 minutes. A couple things I do want to point out. Notice they gave me the updated license so we don't get kicked out at 40 minutes. So we would have been kicked out already. So I'm happy about that. I don't know about you guys. I'm happy about that. So we've got that. So we'll be able to keep one big long thing. Like I said, I'm going to post this that way Melanie can Tyson see it. Not sure where he is today, but if you guys need to go back over it because something you start to do something like, oh, wait a second, what was that? Or you guys can always come to office hours and stuff that I have on Tuesdays and Thursdays. But that's all I have for new material for today. To be honest, I was expecting more questions, so I didn't want to overwhelm you. But that's hey, if you guys get it, then that's great. I'm not going to complain. All right.